Hi everyone and welcome back. I hope you guys had a good Halloween weekend and you're ready for some more statistics. So this week marks what I think of as the final unit in the course. In a typical semester we would have just had our second test and we're looking at the last topic that we cover in data analysis. And overall that topic is going to be something called hypothesis testing. And in this lecture, I'm going to give you an overview of hypothesis testing, as well as an example of one form of a hypothesis test. And then just about everything we're going to do from here on out is going to be some version of what we're doing today. So what is hypothesis testing? To answer this question, I'm going to start with an example. Let's say that there's a judge up for re-election who makes this statement. The average robbery sentence in New Jersey is 5 years. Elect me and I'll make sure that changes, because that's the kind of thing that a judge would say if they were up for election. But what I want you to focus on there is the statement that the average robbery sentence in New Jersey is 5 years. I want you to think back to last week's example and the sample of people with robbery convictions that we talked about that had a sample mean of 10.6 years and a sample standard deviation of 5 years. The question that we're going to be able to answer with hypothesis testing is, based on this data that we have, so a mean of 10.6 years in our sample, is the judge's statement reasonable? In other words, based on the sample we have, is it reasonable to believe that the actual sentence in New Jersey could be 5 years? Or in other words, based on the sample you took, how likely is it that that judge's statement is actually true? And once again, these are completely made up numbers, completely made up judge. I'm actually not even sure if we have elected or appointed judges in New Jersey. So focus on what I'm doing with the math and please don't quote me on anything else. In hypothesis testing, there are a couple of general steps that you follow, no matter what kind of hypothesis test that you're doing. One step is going to be to write something called null and alternative hypotheses. These probably don't mean anything to you right now, but I'm going to talk about what they mean on the next slide. The next thing you'll do is find something called a test statistic. This probably also doesn't mean anything to you yet, but we'll get to that next also. And then finally, based on these other things that you have, you're going to determine how probable your sample statistic would be given some hypothesis about the world. So this statement is a somewhat more formal version of what I said on the last slide, which is that we're going to use a sample to evaluate some statement about what the world is like. But these are these are steps for hypothesis testing in very, very general terms. And so what I'm going to do now is go through some of the specifics of them on the slides here, and then I'll go through some examples on the document camera that will make this a bit more concrete. Let's start with the research and null hypotheses. The null hypothesis, in the context of formal statistical hypothesis testing, which is what we're doing here, is a statement about something that might be true in the population. So let's say we don't really know what the true mean sentence for robbery is in New Jersey, and we're trying to use our sample to get a sense for what it could be. And again, is it reasonable to believe that it's 5 years based on the sample that we took? So a null hypothesis is just some statement that might be true in the population. And so in this example, a null hypothesis would be that the true mean sentence for robbery in New Jersey is 5 years. This is some statement about what might be true in the overall population of people with robbery convictions in New Jersey. And when you're thinking about a null hypothesis, it's just some statement that you want to, see if you can disprove or not find enough evidence to disprove. So you could have a null hypothesis about a lot of things. But again, it's some statement about what might be true in the population as a whole. Another way of writing this null hypothesis is to use this notation, where that h sub 0 means null hypothesis. And what follows, it says that the true mean, so the population mean, which is given by mu there, is equal to 5. So those two phrases right there, the sentence in words and that mathematical phrase, they mean the same thing, which would be that the true mean sentence for robbery in New Jersey is 5 years. Your alternative hypothesis, on the other hand, is a statement about what would be true in the population if the null hypothesis was rejected. So if we had enough evidence to say that the null hypothesis is not true, what would have to be true instead? And in this case, if the true mean sentence for robbery in New Jersey is not 5 years, the statement that's true is, well, that the true mean sentence in for robbery in New Jersey is not 5 years. So if we reject our statement that we're making with the null hypothesis, we would have to come back to this statement that we're saying with the alternative hypothesis. And we can also write it in this way. So here we're writing it with that same notation that we have above, where we're saying that the alternative hypothesis, or H sub A, is equal to, is that mu, which is the population mean, is not equal to 5. So again, the null hypothesis is a statement about something that might be true. Alternative hypothesis is the exact opposite of that. So if we find evidence against the null hypothesis, we'll have evidence in favor of that alternative hypothesis. And this will all make a little bit more sense soon, I promise. And what we're going to be doing is using our sample data to decide whether to reject the null hypothesis. And I'll come back to this wording in a little while as well, but for now, we're always going to say that we either reject the null hypothesis, so we find evidence that the null hypothesis isn't true, or we fail to reject the null hypothesis. So we're saying we don't find any evidence against it, but we'll never say that we accept the alternative hypothesis. All right, so continuing our tour through some of the terms that I just laid out on that previous slide, before I get into examples, we're also going to talk about finding a test statistic. And a test statistic is some sort of standardized value that tells you where a sample statistic would lie on a sampling distribution. So a sampling distribution is something like a normal distribution or a t-distribution, both of which we have met before. And your test statistic tells you where any particular sample statistic, so something like a sample mean, would fall on that distribution. And examples of test statistics are z-scores, or t-statistics, which, as I said in the last week's lecture, is the same thing as a z-score, but for a t-distribution. And another way that you can think about this is to look at this picture here, where I have drawn out a normal distribution on the left and a t-distribution on the right. As I talked about before, a t-distribution looks almost exactly like a normal distribution, and for large enough sample sizes, it's completely identical to a normal distribution. But the difference is that for a t-distribution, you get slightly different shapes for different sample sizes, and you talk about where something falls on the distribution in terms of a t-statistic instead of a z-score. But the idea here is that if you were to take a sample mean, you could find out where that sample mean fell on a normal distribution by assigning a z-score to it. And that z-score would tell you how far off the sample mean is from your mean of 0. Same thing with the t-distribution. A t-distribution is a standardized distribution, much like a standard normal distribution. This means that it also has a mean of 0. And a t-statistic tells you how many standard errors away from that mean of 0 your sample mean would be. So that's what I'm showing there with those lines drawn in the graphs for different sample means you could have, and then a z-score or a t-statistic. So you should be familiar with these ideas already, and what I'm really trying to introduce here is the idea that the z-score or t-statistic, whatever the standardized score is that tells you where your sample mean falls on a sampling distribution, is what we're going to be referring to as a test statistic. All right, a couple more terms to jump into before I get into more concrete examples of how to do this. When talking about whether to reject a null hypothesis, we're going to be talking about how likely your sample statistic is, given some null hypothesis about the population. And we're going to talk about it specifically in terms of something called the p-value. And the p-value is the probability of obtaining a sample statistic as extreme as yours, or more extreme, if the null hypothesis is true. So you can kind of put a pin in that idea for a second. I'm going to show this graphically in a couple minutes, which I think is more helpful than trying to do it in words. But for now, the p-value is going to be some probability of getting the sample statistic that you got, assuming that the null hypothesis is true. And we're always going to be expressing the p-value as a probability. So an example of a p-value could be p equals 0.02, which would mean that there was a 2% chance that you would get your sample statistic given that the null hypothesis is true. Finally, in doing hypothesis testing, as I said before, part of what we're doing is making a decision about whether to reject the null hypothesis. And we make this decision using something called an alpha level, which is just a threshold at which we reject the null hypothesis. And an example would be to say that we would reject the null hypothesis if there's less than a 5% chance that it's true based on the sample we got. And so in that case, your alpha level would be 0.05 to correspond to a 5% chance. And common alpha levels, they're always written as probabilities as well. So common alpha levels would be 0.05, 0.01, or 0.001. And what each of these would mean would be that you'd reject the null hypothesis if there's less than a 5% chance that it would be true, given the sample that you obtained. Reject the null hypothesis if there's less than a 1% chance for p equals 0.01, or reject the null hypothesis if there's less than a 0.01% chance. Sorry, a 0.1% chance if you had an alpha level of 0.001. Numbers. Okay, and in general, you're going to reject the null hypothesis if your p-value is smaller than your alpha level. So if p equals 0.02 and you have an alpha level of 0.05, that would mean that you would reject the null hypothesis. You would fail to reject the null hypothesis if your p-value is greater than your alpha level. So if your p-value is 0.02 and your alpha level is 0.01, your p is greater now, so you would fail to reject the null hypothesis. And this in the last couple of slides I think will be helpful, as you come back to these terms after watching through the whole video. But again, we're going to make this more concrete in a couple minutes. And today in particular, we're going to talk about one kind of hypothesis test that allows you to answer the question that I put on the first slide, which is the true population mean equal to some value? The name for this hypothesis test is a one-sample t-test. And to conduct this one-sample t-test, we're going to follow 3 steps that are consistent with what I just talked about for the general steps of hypothesis testing a couple minutes ago. One is that we'll write out research and null hypotheses. Another is that we'll find a t-statistic for the sample mean. And finally, we're going to decide whether to reject that null hypothesis. So that's all I'm going to say in terms of general terms, and now we're going to go over to the document camera, and for the rest of this lecture, I'm going to talk through these steps with examples and then show you how to do one of these hypothesis tests on your own.